Hi, and welcome to a video on doing conditional probability as it applies to medical testing. So a certain virus affects 1 in every 300 people. So it needs to be fairly clear that on medical tests like this, we need to have an idea of how many people in the population might be affected already, or might be infected, or might have that type of disease. This is not always the case. So originally, when the coronavirus came out, we had no idea how many people were infected. We thought it was very few at first, but we knew, well, there's certainly going to be people who are infected that aren't showing symptoms yet, but also there were a large number of people who were infected who didn't have any symptoms at all. And so that means coronavirus testing was much more mysterious than other types of tests, like if you have the flu or not. So it took a while to develop that test, and there was problems with that. Anyway, so this is a case where we do know a virus infects a certain percentage of people, or a certain number of people, 1 in every 300 people. And then it says a test used to detect the virus in a person is positive. It shows positive 80% of the time if the person has the virus, which means that 20% of the time it doesn't show positive, even though a person has the virus. And that's unfortunate. Someone could be sick with this virus and they wouldn't know it, even if they got tested. And that's 20%, which is a pretty large, 1 in every 5 people. And also there's a problem with the test, and this is true with most testing. They aren't all 100% effective, although 80% is pretty low positive rate. But 8% of the time, if the person does not have the virus, it still tests positive. See, it's positive 80% of the time if they have the virus, and 8% of the time if they do not have the virus. So it's positive 80% of the time when it has the virus, that is called a true positive. That means the true positives are 80%. But notice it also says it's positive 8% of the time if the person does not have the virus. So that is what is called a false positive. That's 8% is a false positive. So that is, if a person tests positive 80% of the time, if they test positive, let's look at this column. These are all for a person who gets a positive test. 80% of the time, it will be true, right? This is called the true positive group. But here, if it's positive and they actually don't have the virus, that means actually negative means actually do not have it. That's called a false positive, okay? And that's when you're told you have something and you actually don't have something. And that's really not that uncommon. It's true with mammograms. They don't say you have cancer necessarily, but mammograms say you're suspicious of having cancer quite a bit of the time, and when women actually don't have it. But so false positives can be a little scary. On the other hand, if this is 80%, I'll put that in here, 80% of those and 8% here. If 80% are actually positive, that means the ones who test negative, that will be 20% of those who are positive will test negative, okay? And if there's 8% here, that means there's 92% here. And that means, see, this 80 and 20 have to add up to 100, and 8 and 92 have to add up to 100%. And these negative tests, if you get test negative and you're actually positive, that's called a false negative. And if you test negative and you actually are negative, that's a true negative. So you really want to be in this group. You want to be in the true positive, so you know if you have it, test right, or you know you don't have it for sure. But there's a large number of people who test negative and they actually have it. That's a false negative. Or they test positive and they actually don't. So let's keep in mind, these are called true positives, positive, positive, false negatives if they test negative and actually have it. So we'll clear all that for the moment, because we're going to need to fill these in. Now, this is all conditional probability that we're going to be talking about here. And let's look at the question. This says, find the probability that the person has the virus given that they have tested positive. Now we know that if this is what they're given, we know if we use this table, we have to look down the positive test column. So it would be nice to be able to fill this in. I told you in the last lesson that we use these tables. They're really nice, very convenient to pick the probabilities off of if the table's filled out. And interestingly enough, all these values are going to tell us how to fill out the table. So if you have 1 in every 300 people, then I advise that you do not use 100,000, because 100,000 isn't a multiple of 300. If you get 1 in every 300 people, we'd rather use either 300 here, or 3,000, or 30,000, or 300,000 perhaps. I like to use really large numbers because then it kind of guarantees that I'll get whole numbers here. You don't have to use large numbers. You could have used 300, but the numbers here are going to start to become fractions or decimals. And then, it's just easier to make arithmetic mistakes. So, I mean, they're bigger numbers, but you don't get decimals if you use a big number like 300,000. So let's talk about how you're going to fill these in now. So you start out with the fact that, it's pink. You start out with the fact that 1 in every 300 people are positive, right? So that's going to tell us what the total is. 1 in every 300. So that's the fraction. And we multiply that by the 300,000. By 300,000. So 1 over 300 times 300,000. That'll, a couple of zeros will reduce out of that. And then the 3 and the 3 will reduce, and that'll give you 1,000. So that gives you 1,000 people. 1 in every 300 means you'll lose 1,000 people, 1,000 people out of 300,000, right? So how do you fill in the rest of the table? Well, if the total here is 300,000, all the people are 300,000 and 1,000 have it, then this you can do in either one of two ways. Well, simple way, you could do 299 out of 300 don't have it, so you could use 299 out of 300. But it's easier just to take the total 300,000 and subtract 1,000 from it. So that's going to be 299,000. Right? If I add 1,000 to that, I get 0, 0, 0, and that becomes 300. Okay, so now is when we start using these percents. This tested positive, now positive 80% of the time if the person has the virus. So this, remember, was a true positive. So this is, remember, this is the right here, TP, that's the true positive square. So the true positives are 80%, and that's 80% of the 1,000. 80% of 1,000 is equal to 800. So that's going to be an 800 right there. Next, how do we find out how many will test negative? Well, a simple way is to take, since this is the actual positive row, and we know there's a total of 1,000, then this value must be 1,000 minus the 800. So we take that 1,000 minus 800 is 200, and that's how we get this value. If you remember, we had a 20% for the negative testing, false negatives. So we could have multiplied 20% times 1,000 and gotten 200 also. But it's easier just to subtract, I think. Now we have the 8%, if you remember, the 8% is the false positives. That means you test positive, but you're negative. So that's the false positive, and that's 8%. So this false positive row, by the way, I should write true positive there. And this would be the false negatives. And then to get the false positives, that was 8%, but that's 8% of what? 8% of the total 299, 8% of 299,000. So that, I'm going to have to use my calculator for that. I want to do it quickly. That's 23,920. Let me give myself a little more room. Again, this is the false positive, 23,920. Now, again, how are we going to get this testing negative value? We could take the 299,000 minus 23,920. Minus the 23,920. So minus 299. And that gives me 275.80. That's right. 275,080. 275,000 and 23,000. That's 20. That's 20. 278, 920, and 80. Okay, so that checks. And those are actual true negatives, right? Those are your true negatives. Now, we pretty much got the chart done. All we have to do is add those columns and then use the appropriate column. So we get 800 plus the 23,920. That is going to give us, there's 0, 0, and 2, 0, 2, 8, 9 is 17, carry the 1, that's 24. So it's 24,720. And for this first question, it wanted to know the probability the person actually has the virus, given that they actually tested positive. So that means we go to the tested positive column. And since the basis, that basis is 24,720, and the actual ones who had the virus is 800, we put 800 over 24,720. And this asks us to find the probability that they've tested positive. Round your answer to the nearest 1/10 of a percent. So if I take that number 800 divided by 24,720, I'm getting 0.032362 . But they want this to be a percent, right? So that means I got to take that and multiply it by I'll put parentheses there, multiply it by 100%. So that moves the decimal 2 places to the right. So that's 3.23 whatever percent, right? And they said round to the nearest 10th, so that should be 3.2%. Okay, let's just verify that. 3.2. I mean, they took it out more than tenths, but there's a margin of error, so you only have to go to the 3.2. Okay, so let's pause. I'm going to pause the video now. Go ahead and pause. I'm going to stop this, and then have you work on the second problem, the second part of that, since we've already filled this in. So I'll pause our recording. Okay, I hope you had a chance to do this problem, and it's similar to part A, only part A, it said that it was given that they tested positive, so we had to look at the positive testing column. This one, it says they tested negative, so that's our condition. This is a conditional. The condition is they test negative, so we have to go down to the test negative column, and we'd have to sum those up, which we did, and that's 275,280. That is our basis for the probability in this case, because we're assuming they're in the testing negative column. So that's the total of testing negative, and it says, what's the probability that the person does not have the virus? And in that column, the people who do not have the virus is the 275,080. So that's why that's our numerator, and that's our denominator. And so now we need to change that to a percent. So I'm just going to do this all in one fell swoop. I'm going to multiply it by 100 as I do my division. So I am going to show you this on the calculator. 275,080 versus 275,280. Times that by 100. Okay, it's just getting warmed up here. It'll open up in a second. I want you to see what this looks like on the calculator. So when we do our, I don't think we want that to be that big. Okay, let me. What? Okay, I gotta make this smaller. Way too big. Okay. So let me clear a bunch of this stuff off. Okay. So 275,080. So we'll put that in first. 275,080 divided by 275,280. I'm just going to go times 100 anyway because you got to get a percent. So put in the percent. Now that's 99.927. So the nearest tenth of a percent, I believe we were asked to round to. So that's going to change. That 2 will not bump that 9 up. Now, I put those in right, 275,80, 275, 280 times 100. Yeah. If you're rounded to the nearest percent, whole percent, that would change it to 100% if that was the case. That would be 100% if you rounded to the nearest percent. But the nearest tenth of a percent, you get 99.99, sorry, 99.9% because the 2 doesn't bump the 9 up. Okay. I thought I did that before and the number was bigger, but might have had a different problem there. Okay, so that answers that. Let's just double check that. There it is, 99.27, and this one we checked already. All right, so enough for that problem. Now let's go to the next problem. And this is similar. It says a certain disease has an incidence rate, which is how often it occurs in a population. This incidence rate is 0.8%. And then it tells us, now this is different. It tells us the false negative rate. Now a false negative is somebody who tests negative. A false negative, you test negative, so you're in the negative column, but you're actually positive. So remember, this is the false negative spot. And it says, and the false positive rate is 5%. So false positive is that they're in the positive test, but they actually don't have it. So this is the false positive. So these are the two false ones. If you're negative, if you test negative, but you actually have it, if you test positive, but you don't have it. So there's your two false negatives, your false tests. You're 7% for this one. So I'll just write this. False negatives equals 7% and false positives equals 5%. Okay. Now I'll go ahead and mark those out and let's get going on the problem. So in this case, it has a percentage of 0.8%. That is fine to leave it as 100,000, okay? If this had said, 1 out of 800 or 1 out of 80, I would have made this a multiple of 800 or 80, but that's not, this is not 1 out of 80 or 1 out of 8. This is 0.8 out of 100. So this just has to be a multiple of 100. If you get a percent, leave this as a multiple of 100. Unlike the previous problem, which was 1 out of 300. We wanted the multiple of 300. So anyway, when we do this, we first want to start with the total. This tells us, this is going to tell us the total positives that we could expect, most likely. So that's now 0.8% is equal to 0.008. Now, a lot of people make errors on this where you have 0.8% because percent means divide by 100. So 0.8% means 0.8 divided by 100. And when you divide by 100, you have to move the decimal 2 to the left. So that's 0.008. So be careful on your percents. This is a real common error. People don't do that correctly. Okay, so we're going to take 8% or 0.08 times the total of 100,000. And that's going to be, that's really 8 out of 1,000. So 1, 2, 3, 1, 2, 3. I think that's 800. You can double check that if you want. So that gives us 800. And now the easiest way to find this is to take your 100,000 and subtract your 800. And that should be 99,200. Right? If you do that on your calculator, you can check that out. So 99,200. And now remember our false negative of 7%, that is going to give us the people who tested negative who actually have it. So I'll just jot in here, this is my false negative right here. So how do I find my false negative number? I take 7% of 800 because that's in my positive by me actually having a column or row. 7% of 800 or 0.07 times 800. Again, just emphasize the arithmetic here. Has always double check your arithmetic. 7% is 0.07 times 800. And now how do we find the positive there? The positive, that is 800 minus 56, right? And that would be 744. Do a simple subtraction there. And now they have 99,200 in this row. We want to fill in this row. Now, this gave us the, if you remember, the false positive. That was over here. They tested positive. This is my false positive box right here. So that's going to be 5%, right? That's going to be 5% of the 99,200. So 0.05 times 99,200. And that is 4960, 4,960. And how do we find this missing number? We subtract 99,200 minus 4,960. So minus 99,200. And that is 94,240. Okay. I'm gonna stop there for a minute. We'll pause this video and give you a chance to try and complete the problem now that we have most of the table filled out. Okay, so the key to this problem is to determine what the condition is. And if you read this, it's asking you to find the probability that a person who tests positive actually has the disease. So we're narrowing it down to the groups. These are people, you're only going to be looking at the people who test positive already. And then if they tested positive, do they actually have the disease? So once again, we're in the test positive is the condition that they have to have met. And we're asking about in people in this group, what's the likelihood they really have the disease if they tested positive already? So that means we're going to have to add up the 744 and 4960. 4 and 0 is 4. 4 and 6 is 10. Carry the 1. That's 17. Carry the 1. And so that should be 5704. Does that sound right? Sure, 40 less. Sure, 5704. So there's 5,704 people in that group. And we want to know if they actually have the disease. That's definitely the 744. And so this problem, it just says give your answer accurate to 3 decimal places. And so you don't really need to convert this to a percent, do you? We're just going to take 744. Actually, you could probably just put in 744 5704 and get 100%. Let's just double check that. Make sure you can. 744 divided by 5704. Submit, and bingo. You could have put it in the fraction. You didn't have to change it to a decimal. It just give it accurate to at least 3 decimal places, so that's exact. Of course, none of this is an exact science because we're just guessing. The incident rate of 0.8% is not necessarily exact, right? We don't know. These are estimates that health officials make, right? And they may not, some are more accurate than others. All right, so enough of that. I'm gonna stop the video now, and we're gonna do a different recording for the last problem, which is expected value.